Now we are honored to introduce our first keynote speaker for today, Insinyur Fauziah Ali, Head of Process Control and Optimization Group, Technical Solution at Petronas, Malaysia. Before we start, let me share a little bit about Insinyur Fauziah Ali. She holds a Bachelor of Engineering, Chemical Engineering from University of Adelaide, Australia, Graduate Certificate in International Management, University of Melbourne. She is the professional engineer with BEM and IEM, and also chartered engineer with ICAM-E. Basically, Insinyur Fauziah Ali has more than 34 years experience with HP, ESO Malaysia, and Petronas, with the longest service at Petronas, approximately about 17 years. She also has a previous experience include roles as refinery planner, process engineer, application engineer, advanced process control engineer, and with project in refinery, gas, and petroleum processes. She will be sharing her insight and expertise in a presentation titled Into the Future with Process Control. Please give a warm virtual welcome to Insinyur Fauziah Ali.
Assalamualaikum. Can you hear me?
Yes, boleh
All
Puan.
right, thank you. Tadi ada apa glitch tadi with Dr. Sam, so I thought I should check with you. I share with you my slides, yeah? I will share my screen. Okay, can you see my screen?
Boleh Puan? Yes.
Boleh ya. I'm trying to go to presentation mode. So thank you to, first of all, Assalamualaikum. Thank you to my PCS and the organizer of the symposium for inviting me. I feel honored to be the industrial representative in what is probably predominantly the academia, and we have students here also. Yeah. It is my aspiration actually to bridge the gap between us in the industry as well as in the with academia, which is why we have initiated some collaborative work with my PCS. So, Dr. Sam, it's good to see you again today, virtually. Today, I'll be talking about into the future with process control. Okay. Of course, this is just my perspective. Into the future is difficult to predict. Nobody really knows. But this is my perspective based on what I see today. A little bit about me, as introduced by Dr. Nahuda. I'm Fauziah. I am Head of Process Control and Optimization in Group Technical Solutions. So I have three groups under me actually. I have the Process Control Group, I have Energy, as well as Process Simulation. So I manage these three groups. I am also the Custodian Engineer and Group Technical Authority for Advanced Process Control. I have 34 years experience in the industry, mainly in oil and gas, because I only spent, I think, 2.5 years in Hewlett Packard. Okay, that's me at work. I'm not that much of a workaholic. I'm also very productive at home. Okay, I'm the youngest in a family of 5 girls. I'm married with 3 adult children, all of them working. I like doing outdoor activities with family and friends. Okay, so you see me there with happiest being outdoor and walking, I guess. It's a very good way to manage stress. Okay. Oops. Okay. So let's go into this a little bit about process control. So what is process control and why? Okay. To me, process control is a discipline within the engineering field that is focused on managing and regulating the conditions of a process to achieve our desired outcomes. Oops. And why do we have that? Because we need to operate the process in a safe and stable manner, produce consistent quality, and now process control is no longer about controlling, it is also about optimizing the process. So it is actually essential in many industries, in oil and gas, definitely, chemical manufacturing, power generation, and food processing. And we'll be surprised, actually, a lot of industries today are very tightly controlled. And that is why we find that, for example, our bread is very consistent. Yeah, the bread quality that we buy, I will not mention brands, but they will taste the same no matter where you go. Every day they will taste the same. So process control is actually essential in a lot of industries. But I will focus on mainly the energy industry because that is where I have been mainly that is where I spent time in my career. Yeah? So a little bit about the evolution of process control. Now, why do we want to go through the evolution? Because each stage essentially lays the foundation for the next stage. So by understanding the evolution of process control, it may help us to anticipate what will happen in the future. So a long time ago, um, control was basically manual based on operator experience. So people physically operate the plant. I guess the way we physically open our own taps at home, right? People will physically open certain valves. That's how they used to do. Then they have basic mechanical feedback control, which are all physical parts linked together. If I may, I guess mechanical feedback control, what still survives today, for example, would be our water closet, our toilet. Yeah, when we flush, essentially there's a float and that will mechanically let in air and then let in water. And then when the water reach a certain level, it will stop. So we always have water in our toilet tank, right? So that is the mechanical feedback controlling level. It is quite rough. Yeah. Proceeded to pneumatic control systems, which are reliable but not very precise, and they're quite bulky. So later in the 50s, 60s, we had evolved to analog digital controllers. They are more precise, they are quite fast, and they are less bulky. And there we have electronic PID controllers. So in the photo I show below is the evolution from the bulky pneumatic controllers to the electronic PID controllers. From there we built later in the 70s onwards, right? We go to digital control systems. Sorry, I am on PowerPoint mode. So if somehow I get disconnected, can somebody call my handphone? I know Professor Sam has got my phone number. Okay. So moving forward to digital control systems, we have PLCs, which are maybe smaller scale but flexible, right? The scope is maybe more on individual equipment. We have DCS, distributed control system, and that involves multiple processors. We have SCADA. We have SCADA for large-scale process supervision, mainly for data acquisition over a large geographical area, usually. And the device integration have become more simplified, more integrated. We can now link with enterprise resource planning. So for example, from the planner, we could, if we wanted to, depending on the demand, actually directly control the process. Yeah, we have multivariable predictive control. which essentially controls the whole envelope, the whole process, using model predictive or model predictive control, controlling many variables to achieve a common objective. And nowadays we have wireless and mobile technologies, and that adds a lot of flexibility. Without doubt, now the line between IT and OT, information technology and operation technology, is becoming a little bit more blurry. They have begun to merge, right? So cybersecurity becomes a critical concern. I think not too long ago, OT, operating technology, was segregated from IT. They were the purview of the control engineers and the system engineers. The IT belonged to the IT experts. They were physically segregated, and their policies were different. They follow different policies, but with the merging of IT and OT, things are more, data has started to flow more freely. So cybersecurity is actually now a critical concern. So if we talk about going into the future with process control, then I would say key questions to be asked would be, what is the future, right? What is the future? What type of processes will there be for process control to operate and optimize? Are we having the same processes that we are today? We have refineries, we have gas plants, or will there be different processes? And also, what will be the control technologies of the future? Will it just be, for example, multivariable predictive control, or will there be other control technologies in the future? So I see that among the major concerns for the future are, number one, many resources are depleting, right? Non-renewable resources like oil, gas, they are depleting. Minerals are depleting. For example, a lot of natural resources we cannot replace. There's also climate change and environmental concerns. We know that we have a global temperature rise concern, and that has led to the Paris Agreement. And also we are now seeing environmental concerns like pollution. We have smog. Yeah. Of course, there are some people who conspiracy theories saying that climate change is a hoax or whatever. But being engineers, we follow science. So we say climate change is real. Okay. And there's also major concern of waste. If we just Google waste, we can see all around the world mounds and mounds of waste are piling up everywhere, found their way into the ocean, for example. So this is an area of major concern in the future. So with these concerns, going into the future, there will be a lot of focus on conservation of resources. Yeah, this will lead to asset operational excellence, where we will use less utilities, less fuel, less water, less steam, etc. So we need to get more for less, essentially. There's no wastage. We need to operate very, very efficient manner. Also, we will be finding renewable alternatives, right? So that we do not have to worry about depletion of resources. To combat climate change and environmental concerns, we will also find cleaner alternatives. And also to combat waste, we will find technologies to enable circular economy. So in the energy landscape, what does that mean? We will find cleaner energy, and some are renewable. So gas is a cleaner energy compared to, for example, coal. And many countries have got gas as their definition of clean energy. Yeah? There's also solar power, hydropower, wind energy, as well as bioenergy. Okay. Um, there will be avoidance or phasing out of environmentally unfriendly sources. For example, coal. In fact, Malaysia's Dasar Tenaga Nasional released in September 2 years ago, September 2022, already specifies that there will be no more new coal-fired power generation. So that is part of the national phasing out of coal energy, coal-derived energy. There will be new technologies to recycle waste. In our case, could be waste to energy, right? Or waste to plastic. Um, and for example, waste, it could be even plastic waste, it could be municipal waste, for example. And I'm happy to say I'm the proud owner of a few pairs of trousers that are made from recycled plastic. I bought them out of curiosity. They're a little bit coarse compared to maybe our normal cotton trousers, for example, but you can find in the market already clothes made of recycled plastic. Therefore, with these things going on, what are the supporting technologies? So one of them would be energy storage. For example, if we have solar energy, we need to have technology for energy storage, because in Malaysia, I believe solar energy can only generate energy for about 4 hours. Although it feels that we are hot all the time, but in terms of solar, we can generate about 4 hours with the existing technology. We need quite a big energy storage if we are going to go to solar. Similarly, yeah. So, and also we will need supporting technologies, for example, for battery cooling, right? Because if we just look at our EV cars, the batteries do generate a lot of heat. So there are new materials also required. And what does it mean for process control? And I include optimization, because now process control is not meaningful without optimization. We no longer aspire to just control the plant. We combine with optimization. So what does it mean for process control and optimization? Number one, we will be optimizing, for example, real-time blade angle adjustment for wind farms or solar panel angles for solar energy, so that we can we have a longer period for energy capture. We increase the amount of energy captured. We optimize the amount of energy captured because we are able to adjust these things in real time, as well as we reduce wear and tear and improved efficiency. These are examples of what process control and optimization can do. In real time, there's also real time monitoring and control to regulate new technologies. So we could go into control and optimization of, for example, fermentation in biofuel production. We can use predictive technologies in combination with eventually probably PID control to maintain optimal microbial activity. Because biological processes are very sensitive and very difficult to control. Okay, so maybe we control temperature, humidity, sunlight, population density, and age. All these are to optimize our production of biofuel. We could also use predictive technologies to overcome a wide variation of feedstock in reprocessing waste. For example, in waste to energy, typically waste feedstock is highly variable in the feed quality. It's not like I am producing producing ethylene from ethane. My feedstock will be ethane, and they are quite consistent in quality. Processing waste will have a lot of variation in qualities, and definitely predictive technologies will be very helpful. Um, there will be a prevalent use of predictive technologies and more advanced algorithms for process control in today's emerging process. So, what today is maybe not yet commercialized or whatever, still maybe trial pilot plan. Eventually and very soon, we will implement predictive technology and advanced algorithms for this. Also prevailing use, including that, is prevalent use of digital twins, including in renewable energy, real-time closed-loop optimization, managing technical and economic trade-offs, as well as real-time change in energy demands. So these are high levels of control and optimization that I believe we need to be prepared for. So food for thought, are we rising to the challenge? Are we ready? Number one, can we embrace the new processes that are still developing stage or have not been developed? When people are talking about, you know, from gray sources to blue, green, turquoise, whatever, right? Are we ready to embrace that these are the new process? These are the processes of the future. Okay. Are we ready to be part of development of new processes? If I'm going to be producing, for example, hydrogen fuel, is the control ready to support this new process? If I'm producing green methane or whatever, is process control ready to develop technologies, ready with the technologies to control these new processes? Are we able to learn, unlearn, and relearn? Some old technologies have got to be let go to be replaced by new technologies. Are we so attached to the old technologies that we reject technologies? Also, are we able to adapt and apply new technologies intelligently? Because not everything new is better, right? Not everything old is good. So if we are going to apply new technologies, do we have that critical ability to apply these technologies where appropriate, select technologies where they are appropriate, resist the urge to apply technologies because they are the latest and greatest? So also, are we ready? Because these are, I know that we have a lot of academia here. So are we ready? Are we preparing our future engineers physically by teaching them topics that are fast emerging, industrially applicable, and beyond conventional process control? Or are we teaching them topics that are relevant maybe 20 years ago, but they are not prepared when they come out to industry, that industry is applying something totally different? So this is about teaching them the fundamental topics for today and for the future. Also, are we preparing our future engineers mentally? Because we need to overcome the mentality that was inculcated during school days, I think, in maybe primary, secondary school days. Teknik menjawab soalan. You have to know how, you have to learn how to solve the problem before your exam. And then we go to camp SPM or whatever, we have to overcome that mentality. there will be no more achieving excellence from rote learning. And doing trial exam papers from different states, we do the last 10 years of past exam papers, for example, it will not work. This kind of attitude will not work in the future because there is so much unknown. Okay, so critical thinking at solving new problems is essential because the problems that we see, the challenges that we see have not been seen before. So we have to be agile, adaptable, and comfortable in working with the unknown. So these are the essential qualities of our future engineers. Otherwise, they will be very stressed out and they will avoid doing engineering because they are not comfortable with new things and unknown things. With that, I end my speech with a quote by Steve Jobs. Innovation is the ability to see change as an opportunity, not a threat. So there is a lot of innovation going on now and in the future. So we have to embrace that as an opportunity and not be stressed out and not be afraid of them as a threat. So thank you for listening. I'm open for any comments. If you allow the participants, I noticed that the comments are disabled. But if you do have any questions or any comments, I also welcome them. I hand back to the oops.
Okay, thank you, Insinyur Fauziah Ali, for that inspiring session. So, since we still have a time, so any question from the audience or participants, if you guys have any question, you may raise your hand. You may raise your hand, so the technical team will allow you to speak out, or otherwise you can chat in the Q&A session. Yeah, Q&A column. So any question from the
Chat is
audience or
disabled. Saya
participants?
tengok chat is disabled. Just now I was yeah.
Okay, there's
But
one
Dr. Sam,
from
yeah.
Dr. Syamsul.
Bagi Dr. Kamal dulu kot, Dr. Kamal.
Okay, Dr. Kamal.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much, Fauziah, for your presentation today. I have two simple questions, basically. The first one, since you come from the industry, you have a lot of experience, and also you have so many experience in handling the new engineer joining your company. The first one that I would like to ask you is about the fundamental of process control that we teach in our university levels. For example, there is a question about from the student about is it compulsory now that we need to teach them how to come up with the transfer functions? How that we come up with the modeling, started with the modeling and then mass and energy balance after that. Then we use the Laplace transform, and then after that come up with the manual transfer function. Since we have a lot of technology now, that's basically in a single click, the student able to come up with a simple transfer function. So is it a necessary now in this kind of digital era that we still need to teach our students how to develop transfer function manually? That's my first question. Can I proceed with the second one? Ataupun
yes,
you nak jawab dulu?
Boleh juga jawab. Although I have actually started jotting down on my handphone what was your question so that I don't forget. This is my opinion lah. From my I think if we I think it's a fact that many people don't like process control or afraid of process control. And if we teach transfer function at the start of process control, we will turn people off. Right? We somehow maybe all this Laplace is very scary to many people. and the only maybe the only people who will end up working with process control, with transfer function, will be the process control engineers. And to me, I only actually mess around with transfer function when I become an experienced process control engineers, because now a lot of modeling is already done by software. What I think the aspect of process control that is essential to everybody, all chemical engineers or more chemical engineers, even if you are a process operations engineer, or if you are a designer, or if you are control engineer, is number one, sebelum you understand, before you understand function, is how do you develop control strategies, right? So that when you design something, you already design together with, you have control strategy, controllability at the back of your mind. And for students, I do some final year examiner, whatever. Sometimes I start seeing two flow controllers on the same line, right? And I start seeing one flow controller and one temperature controller, but the temperature controller is controlling the flow on the same line. Final year. So to me, if this is the concept that the students do not have, transfer function is the next level to no need lah, no need. Okay, so I think in order of priority, I would say learn to develop control strategies to support the process first. In my experience, when I have done modeling as an experienced engineer, when I want to change certain models in some software, they allow me, and that is when I dig into the transfer function and I change the parameters in the transfer function. Okay, and then that is when I look up. Of course, obviously, because I forgot also what was taught in school, then I look back into the transfer function. But to start off my career as even my career as a process control engineer, transfer function is less important. Not less important, less used lah. And there are other aspects of control engineering that is used, as well as used more widely even by other disciplines, so that we don't have designers controlling in a very weird manner, for example. Process engineers have been known also to request changes in control strategy, because once they are experienced in process, they know that the control scheme doesn't work. They can use their control knowledge to modify and suggest, I think I can do this, for example. So transfer function is relevant, but maybe I do not know how it is taught. If it's taught the first lesson or the early in the course, I think it will put people off process control. And certainly what I find that many people are not willing to go into process control because it is perceived as being very difficult and abstract.
So maksudnya macam ni, it should be taught in the advanced level lah, mungkin dalam advanced process control ke. If you want to modify some of the algorithm within the system.
Yes, yeah, or maybe teach towards the end of your class or something, and it's process control. It's not totally about transfer function.
All right.
Yeah.
Okay. Can I have the second one, Sam? Can I have the second one, Sam? All right. Thank you. The second one also related with the first one, which is about that we have the advance in the process design. We have advance in the process simulations. So we know that when we want to control something, we need to come up with the basic principle of the design. So since we have this kind of advancement in terms of process design, in terms of process simulation, so how that basically it will impact the process control. Sometimes if we design it so very well, exactly very well, some of the system basically react as a self-regulated process. Right. So in the future, how that you look this in terms of the advancement in terms of process design?
Did he do? Somehow I got disconnected. Can you repeat your question again? I'm so sorry. I thought what happened?
All right.
I wasn't. Yeah.
Basically, since we have digital era already now, so we have the advancement in terms of process control, in terms of process simulations. So in the future, how that this advancement in terms of process design and also process simulation will affect our process control activity. For example, if we design a certain process, exactly like we can able to come up with the what we call it so-called self-regulated process. So if we experience this, basically no need for us to control the process. Okay, but that is something which is very impossible. But is it possible? So how that you look at this kind of situation in the future, for example?
Okay. If you can look at design, for example, people used to design maybe at steady state, right? Now what we do is we at design stage we also look at starting up, shutting down, as well as transferring grades, handling disturbances, for example. And our process control team actually have got a portfolio under Puan Andrini that is called operability and control, where actually the assumption is, of course, everything is designed properly, but we do this at actually FEL 2 stage or FEL 3 stage, basically at design stage, where we look at the controllability. So we may recommend certain control strategies, we may recommend additional instrumentation to enable optimization. We may recommend technologies that can manage, for example, grade transitions, etc. And this is actually done at design stage. So we are also involved in design. For example, together we provide the expertise. So we are part of this advanced design process. For example, yeah, because we know best what are the advanced control techniques out there. So I don't see that design is separate from control. I see us working together, for example, in design. And I have been, as a control engineer, I have been part of design doing HAZOP, right? HAZOP, because I provide a control perspective on the normal HAZOP methodology. I have been part of P&ID review because I make sure that the control strategy is right. I can recommend differences. I can manage things like the what if this unit is down, what if I need to embed certain flexibility, and that requires a high level of understanding that is not expected from a design engineer. So I think we form part of that advanced method. But control also have got advanced methods on its own. For example, now people start talking about doing ML models. One of our multi-variable predictive control software that we use actually have got ML models embedded as one of the algorithms, which I haven't tested out, so I do not know whether it is more superior to the standard, to the current variety of algorithms that we have. So it is already embedded inside the current third-party software. So I believe on our own, we have our advanced methods, but we also form part of the improved version of other disciplines.
Okay, thank you for your answer.
Okay, thank you, Dr.
Dr.
Kamal, Dr. Sam.
Dr. Huda, maybe there are a few questions in the chat box, Q&A.
Okay.
Can we just finish that one first?
Okay. Okay, Fauziah, there have a few questions here from Dr. Jabron. It is important to teach students about PID control, example, tuning procedure or at CISO, SISO or cascade control system. Is it important to teach students? What do you think, your perspective on this?
Is it important to teach them PID control? Yes. It's important to teach them control, whether it is basic control or it's cascade or it's it is important because, like I mentioned earlier, the control build on each other. I have a PID control, and on top of that, I may have cascade. Further up the pyramid, I may have multivariable predictive control, for example, but I still need to control my PID. PID only will look at single loop, but if I have a more advanced method that look at the whole process, right, then I still need to control PID loops, because I do not want my optimizer to be running in seconds, for example. So PID has to work because usually they are the executors of commands, and where the commands come from may come from, of course, higher levels of optimization. So I believe PID is necessary. It is what I was mentioning earlier was that focusing on a transfer function, at the start of control engineering class can be scary for people. And for us, in Petronas, we have our own course for control engineers, where we cover single loop, we cover intermediate like cascade, split range, and we cover advanced regulatory control. We have hands-on on tuning as well. And in that course, even if that course does not require you to actually be very proficient in transfer function actually, and they can still do a good job in tuning actually. But tuning is necessary. I think it has always been necessary from the pneumatic days. It's still necessary today. Yeah.
Okay, thank you. Perhaps we have another question from the chat box. From Siti Nur Azrin. Assalamualaikum, I am Fauziah. Can you share what are the Petronas approaches or technologies on real-time optimization technology so far?
Oh, okay. Waalaikumsalam. Thank you. Of course, we do have our base layer, our regulatory controls. We try our best to make it tip top as the most fundamental layer. So single loops must work, and then our cascade, split range, etc. must work. Our combustion control must work, and then we do have quite well established our multivariable predictive control. We have advanced process control, which includes multivariable predictive control. It includes inferential technology. It includes what we call it, procedural automation, right? Where we do steps, for example, transition or startup, for example, it is automated. We also have begun, and it is growing, real-time optimization, or what we call RTO. It is also and these are RTO can be closed loop or open loop. We have many people who have begun doing what we call advanced analytics, mainly doing using AI for models and optimization, mainly for open loop. But they are all performing different functions, right? So for single loop, maybe they are just to change the set points or to reject any disturbances. So they are all performing from control to optimization. At different layers, they are performing different functions.
Okay, thank you, Fauziah. So maybe last question from Dr. Sam.
Ada masa lagi eh?
We still have 10 minutes.
Okay,
Soalan
alright.
daripada bos ni takut ni.
I just want to ask one question, because since you mentioned about future of process control, right? Currently, the research on processes is going on smaller equipment, right? They're testing the processes in a miniaturized system, right? So how do you think the process control formulation theories as well as the design of the control structure going to be differ for a miniaturized system? For like a microreactor, for example, or a combined technologies between like RD, reactive detection column, and whatnot. So, what would be your take on that?
I think current when we say new technologies, right, they will start off being tested in the lab before maybe going on to pilot scale. In the lab, there will be less. In the lab, essentially control is not really there because everything is quite fixed. For example, if I want to have a certain mixture of gas, I will have my individual component tanks and I will mix them. And the tanks are pure because I bought them with a certain purity, right? But then when I move out to pilot scale or even later to commercial scale, that's when things will start to happen. I will have variation in feed, right? Then I will have variation even in temperature. Maybe inside the lab, the temperature is always 15 degrees. But if anything at pilot scale, will be subject to ambient temperature, will be subject to rain or shine. So I think control is still essential. Probably in some cases more essential because, for example, in case of waste, to manage the variation in feed is even more essential for process control. We have to be very innovative in how we predict the effects of certain unknowns. For example, municipal waste, we don't really know what's the composition. It can be anything that people throw out. We have to be very innovative in how we're going to manage that change. But there are maybe some other technologies which are more by nature. They are subject to less disturbances. So probably the complexity of control is less in that area because the process is less complex. Control is only as complicated as the process, right? So if I'm making some green version of certain petrochemical, I think the complexity is not reduced. It's not reduced. So there will still be process control. It's just that the technology is different, making use of different catalysts, using more friendly catalysts, but the complexity is, I believe, is just as complex, requiring process control.
Okay, thank you, IR Fauziah. Perhaps we have one question, if you may answer in 1 minute, from Prof. Azlan. How much of artificial intelligence technique are being implemented at Petronas at this moment, since this is the latest in-thing issue globally?
Oh, it's very people are very active in trying this out. So far not in closed loop. We are managing it if eventually it comes to closed loop, but different pockets of people are doing that in open loop for monitoring and predicting.
Okay, thank you.
1 minute time.
Thank you, IR Fauziah, for entertaining the questions. It's very insightful session.